Hello there, Mr. Sutton here, bringing you the AB Calculus 514 Extra Practice Number 6 solutions on integration by substitution with indefinite integrals. For this problem, we're trying to find the indefinite integral for this expression. Now, the key on this one is that we have an inner function in this exponential that the derivative of this inner function is somewhere else in the problem. We have an x to the fifth here. The derivative of that involves an x to the fourth, and hey, here's an x to the fourth. So let's try doing this one with integration by substitution. Let's let u equal 5x to the fifth minus 4. And then du is going to be 25x to the fourth dx. So then dx is really just du over 25x to the fourth. Substituting back into the original, we can write negative 125x to the fourth times e to the u. And then dx again is just this du over 25x to the fourth. Well, these x to the fourths are going to cancel, so that's nice. Negative 125 over 25 is going to be negative 5. We still have an e to the u du left over. Now, the antiderivative of this expression is just negative 5 e to the u plus c. And then we can substitute 5x to the fifth minus 4 back in for u. For this problem, we notice that there's a cotan in this denominator and a cosecant squared in the numerator. Now, cosecant squared is the derivative of cotan squared, so we might be able to do this by treating cotan as kind of an inner function and then using integration by substitution. So let's try it out. Let's let u equal cotan of 4x, and we'll see if this works. So then the derivative would be negative 4 cosecant squared of 4x. And then dividing by all that, we have du over all that craziness equaling dx. Now let's substitute some things back in. We can write this as negative, 8 cosecant squared of 4x over u, and then dx again is going to be du over negative 4 cosecant squared of 4x. So these cosecant squared of 4x's, those can cancel. We have a negative 8 over a negative 4. That's going to become a 2. So we have 2 over u, or 2 times u to the negative 1, either of those, du. Now the important piece here is that the antiderivative of 1 over u, that's going to be ln absolute value of u, and we have that 2 kind of along for the ride. Don't forget the plus c. And now plugging back in, we can write 2 ln absolute value of cotan of 4x plus c. For this problem, this one is especially tricky if you don't already kind of have a sense of where you want to go with this. The key to starting this one is recognizing that 16x to the 8th is also capable of being written as 4x to the 4th squared. If you see this, then you might also notice that the derivative of this inner 4x to the 4th function, something with an x cubed, is elsewhere in the problem. So this might lead you to think, well, integration by substitution could work here. So let's let u equal 4x to the 4th and see what happens. So then the derivative is du equals 16x cubed dx. And then du over 16x cubed is the same as dx. Substituting back in, we can write 16x cubed over 9 plus u squared. And then dx is really du over 16x cubed. 16x cubes conveniently cancel, so we're just left with du over 9 plus u squared. Unfortunately, 9 plus u squared is still not what we need down there in order to use one of our antiderivative techniques. But it's pretty close to the antiderivative, or it's pretty close to 1 plus u squared, which would be an arctan for an antiderivative. So to get us a little further along the path of happiness here, we're going to try to get a 1 plus something squared situation in that denominator now. So I'm going to factor out a 1/9. So these 16x cubes are gone. I'm taking out a 1/9 from the whole integral now, leaving me with a 1 plus 1/9 u squared downstairs. And now I can rewrite this 1/9 u squared. I know I keep rewriting this thing down here, but now I can rewrite it again as 1/3 u parentheses squared. And at this point, I have my classical arctan situation. So this is going to be, for an antiderivative, we're going to have arctan of 1/3 of u multiplied by or divided by the derivative of this thing. So that means we're really multiplying by 3. We've got 3 times 1/9, which is going to be 1/3. So when the dust settles, we have 1/3 arctan of 1/3 of u plus c. And finally, we can substitute this 4x to the 4th back in here. So when we do that, we're going to end up with 1/3 arctan of, now be careful because we have a 1/3 in here. So this is going to be 4x to the 4th over 3 plus c. On this problem, I notice that I have an inner function, 1 minus sine of x, whose derivative, which involves a cosine of x, is up here. So let me try substitution for this. Let's let u equal 1 minus sine of x, and then the derivative is going to be negative cosine of x dx. And then dividing, we have du over negative cosine of x equals dx. Substituting back in, we can write this as cosine of x over square root of u times du over negative cosine of x. And these cosines are going to cancel. I have a negative still, and I'm going to rewrite this as u to the negative 1/2 power, and we still have that du kicking around. Using my reverse power rule now, this bumps up to an exponent of 1/2, and then dividing by 1/2, really multiplying by 2, we have negative 2u to the 1/2 plus c. And then I can plug in 1 minus sine of x for u and call it a day. For this problem, trying to find the indefinite integral, it's a little bit tricky because there's no way to really simplify these trig functions. However, if we take a look at this 5th power here, this is really sine of 3t to the 5th power, so it's an inner function of sine of 3t, and the derivative of that inner function, which involves a cosine of 3t, is elsewhere in the problem. So this is a good candidate for u substitution. Let's start by letting u equal sine of 3t, and then du is going to be 3 cosine of 3t dt, and then we can say du over 3 cosine of 3t is the same as dt. Substituting back in now, we can write this first term here as u to the 5th, and then we still have a cosine of 3t. dt now we can rewrite as du over 3 cosine of 3t. Cosine of 3t's are going to cancel. We still have a 1/3 going on, and a u to the 5th and a du. Bumping this exponent up to 6 and dividing, we have 1 over 18 u to the 6th plus c. And then finally we can substitute sine back in here. So this is 1/18 sine to the 6th of 3t plus c. For this problem, they're telling us to use the substitution u equals 4x minus 3. So they're making it pretty obvious they want us to use integration by substitution here. They want us to rewrite this integral as something that's equivalent to it in terms of u. So we're not being asked to go kind of all the way with substitution, but we are being asked to rewrite this a little bit. So let's at least start the process of substitution. We would do that by taking them at their word and letting u equal 4x minus 3. The next step after you let u equal something is always to take the derivative of that whole equation. So we would write du equals 4 and then dx. Next, we would divide by 4 to get dx by itself. And now substituting back in, we can write the integral of x times u to the 10th, and then dx is going to be du over 4. Now this is good as far as it goes, but it doesn't match any of the answer choices because we still have this x kicking around. So to get rid of that x, we're actually going to have to go back to the stuff over here, and we're going to have to rewrite this initial equation so that we have x isolated and we can express it in terms of something with u. So if I solve this equation here for just x, I can write x equals u plus 3 over 4. And this now allows me to swap out this x here for something that only has u's in it. So this x I'm going to rewrite as u plus 3 over 4. This doesn't match any of the answer choices either, but it at least only has u's in there. So now we can try to kind of untangle this and turn this into something we see over there. So we have a 4 in the denominator over here and also over here. I can multiply those together and take out a 1/16 from the whole thing. And then inside I have a u plus 3 in a parentheses still times u to the 10th. Distributing that out, we can write u to the 11th plus 3u to the 10th. And then I still have that du hanging out. So this is going to end up being answer choice D. For this problem, I'm trying to take the antiderivative of this expression. The key on this one is that I have this inner function, and its derivative is elsewhere in the problem. So I can try substitution on this one. Let's start by letting u equal 6e to the x plus 3. And then the derivative of this is going to be du equals 6e to the x dx. And now I can divide by 6e to the x to get dx by itself. Substituting back in, I can rewrite the original as e to the x times sine of u. And now dx is really du over 6e to the x. E to the x's are going to cancel. I have 1 over 6 times sine of u du. Antiderivative of this is going to be negative 1 over 6 cosine of u plus c. And that doesn't match the answer choices because it looks like these are in terms of x. So if I substitute 6e to the x plus 3 back in for u, like so, now I'm going to get one of the answer choices, choice C. On this problem, I've got this integral of 2x cubed plus 1 quantity squared, and I want to know which of these integrals down here this thing is equivalent to. So this one is a little bit tricky, but it's generally best to go with what you know is going to work. For example, we know that it's okay to expand this inside the integral using the a squared plus 2ab plus b squared shortcut here. So I could just rewrite this as 4x to the 6th plus, and let's see, if I multiply these and double it, this is going to be 4x cubed plus 1 dx, which is answer choice A. But now you might be wondering, well, what about these other answer choices? Aren't some of these also possibilities? Well, choice B, we're not allowed to actually split up an integral with multiplication. We can split it up with addition, but there is no integral rule for undoing multiplication like this. So choice B is just wrong. This is not something you can do with integrals. Choice C, this is involving a substitution. If we let u equal 2x cubed plus 1, then yeah, we could rewrite this part of the integrand as u squared. However, to also put a du in there, we would have to convert it. So we would have u equaling, let's see, 6x squared, and then dx would actually be equivalent to du over 6x squared. So just writing du here is wrong. You would also need a 6x squared in the denominator. They didn't do that, so this is not a correct conversion. And the 1 over 6x squared I was just talking about, even if you did put it in there, you can't just take it out of the integral like this. You can take out constants from integrals, but you can't take out things that have variables in them. So choice D also incorrect.